Hello everyone, welcome back to my channel. In this video I'm going to be showing you my first prototype in trying to recreate the priority hold or I hold circuit used in 1A2 phone systems. These are the original card numbers needed. There were actually two different cards, the 429A supplementary hold detector, and then you needed a special flutter generator in order to get the very rapid blink pattern. And the purpose of this circuit is you would have two different hold buttons on your key phone, and so far nobody's actually seen one of these key strips, but it's supposed to have two hold buttons in the same strip, your regular button and then one just above it for priority or I hold. And if a line was placed on I hold, which I hold or priority hold are actually two different systems. I hold would, if you pressed a button that was meant for I hold, so if you're on call on a line and you press the I hold release key, it would go ahead and put that line in a rapid blink pattern, but only for that phone that placed it on hold. And for all the other stations, it would just look like a regular hold. To me, that's not very useful because it's, I might as well just go ahead and make priority hold, which would basically show the rapid blink pattern on all stations that were connected. So then you can see that that customer or that person needed to be answered prior to the regular hold lamp. So as far as I can tell in the documentation and stuff, it actually would say how many times per second it needs to flash, which I will go ahead and program that later on. But essentially these cards are almost impossible to get. The supplementary hold detector and the flutter generator are both extremely rare, and they could only do two lines. So you could only have two lines for the supplementary hold detector. The flutter generator, I think, could supply it to more lines, so you could have more than one, I think. But anyway, this one is going to do 4, so it's going to actually have larger capacity than the original. And I'll go ahead and explain to you how this is designed to work. Currently, I have not done any testing, but all of my schematics and thought process behind it, I think, seems pretty sound. And I'd say there's a pretty good chance this will actually function. So basically, I'm using an H bridge as the flutter generator. So this is going to generate the rapid blink pattern off of the Arduino. And the relays are switching the line lamps. So on the side here, I have 5 screw terminals. 4 of them are the regular lamp leads. So the regular lamp leads that come off of your key system and go to the phones, you would go ahead and take them off of your punch block or intercept them somewhere and put them in here. This is line 1, 2, 3, and 4. And then this last one here is motor ground, which I'll explain in a second. That has to do with the detecting and maintaining the hold function for the Arduino side. But basically, so this still receives the regular flutter generator and your regular line card lamps, all of the regular stuff, and that's connected to normally closed of all 4 relays. So normally closed for all of them, and then the common terminal is going to the blue, orange, green, and brown wires on this Cat6 wire that I have. So this will then be punched down. So the white side is the lamps. The So basically white blue, white orange, white green, and white brown are the lamps. Blue, orange, green, and brown, the solid color, are the sensor wires. I'll go ahead and actually finish explaining the relays. But basically, normally closed is connected to your normal lamp supply. Common is going to the lamps on the key phones. Normally open is going to the flutter generator. So then if I trigger the Arduino and say, okay, this is needing to be priority hold, it'll turn on the relay and trigger my flutter generator, and then it'll go ahead and do the rapid blink pattern for that line. And I can switch all of them on if I want to and have all four doing the rapid blink, or just one or two or whatever pattern, because these relays are all wired separately to the Arduino. And also, if you're running relays on an Arduino, make sure you have a clamping diode, because otherwise it'll kill your board. So I've never killed one of the Arduinos. I just know from experience you need to have clamping diodes to make sure that when you release the relay, it doesn't cause a huge back spark that then goes ahead and kills your board. So then, as far as detecting and maintaining the hold, I have wired the blue, orange, green, and brown solid wires to the analog 1, 2, 3, and 4 pins. So then, how the supplementary hold detector works is you have your A leads for your line cards. So you can go ahead and connect another wire to the A lead. And here it's even showing the 400 type line circuit and the A lead. And so then you can go ahead and detect that if there is ground connected, that it will have the relays disengaged. So nothing needs to happen if there is the ground connected to it. But if the supplementary hold key is pressed, you can see that how the supplementary hold works is ground is normally connected to the lines, to the A leads. But if you press the supplementary hold, it will temporarily bridge the supplementary hold wire to whichever line is being put on hold. And you can sort of notice this with any key phone. If you press a line and then go ahead and press the hold button, they get released at the same time. So when you press the supplementary hold button, it's bridging the supplementary hold wire to that line, or to this line. So it's actually connecting this wire, the supplementary wire, to whatever line card's A terminal temporarily. So what I'm going to go ahead and do is, most likely I'm going to have, I think, negative ground, just because the Arduino operates better with negative ground. So I'm going to go ahead and put, the Arduino is going to have its own 5-volt power supply, and I'm going to connect a negative wire grounding the Arduino to my phone system, so that then the negative 5 volts is going to be connected to my A lead, or my master A lead going into the phone. And so then I can go ahead and punch down the solid blue, orange, green, and brown wires to the A leads of the lines. So the A leads on my punch block for whatever lines I want to have with the priority hold. And then when I press the supplementary hold button, I'm going to have that be positive 5 volts. And this is the only part that I haven't 100% worked out yet, since I have not written the code for this, and I have not tried troubleshooting if this even works yet. But what I'm hoping to do, since these are analog read, I can go ahead and say if it's directly shorted, then that line is being accessed. And if it is raised up all the way, then that means that that line, it needs to be on priority hold, and it'll trigger the relay. And then to release it from priority hold, there's two ways that a line can be released from hold. Is it can be re-accessed. So then that would mean that if that A lead is brought to ground again, it needs to release it and switch the relay off. Or if the line hangs up, where if the person hangs up, you don't want this to just keep doing the flutter generator forever. So then that's where this last wire here comes in, which is a motor ground sense. All key systems have a master motor ground, where when a card is triggering the interrupter to start up, whether it be for ringing or for a hold condition, there will be a contact on your key system that is going to be shorted to ground to keep the motor going. And then the line card will automatically release the motor if whatever client hung up. So then you can go ahead and just connect this last terminal here to your main generator ground. And so I'm using the can't think of the name right now, but the large KTU panels, 584C, there we go. So I already have traced and figured out where the 584C master ground is for the flutter generator, and so that's where that will be connected. So then I can for sure know that if that's grounded, we know that the generator is going, and then it will keep these on hold. And then if the generator stops, then we just go ahead and release whatever relay. And so by default, if this is powered off, it will be bridging the regular lamps, and the telephone system will work as normal. And then if we power this up and we start doing these A leads with a supplementary hold, then it'll just switch the relay to this. And all I've done here is the H bridge is very simple, that it just has pins here on the upper part that I've just soldered wires on the bottom. These first two pins, which go to this block, those are just being controlled by pin 6. And so then I've basically just done 2. The reason why is to double amperage. So if I, for some reason, get a ton more key phones, this should still be able to handle a ton of line lamps. Because I believe that the peak current for just one phase is 2 amps. And if I'm doubling them both to do the same function, I should have more than enough amperage to run some lamps. Because if I get up to the point of this blowing out, my I think my fuse will actually trip on my line lamp supply. So I'm not really worried about this thing burning out from lamps. Then up here on the top, I've added some bonus features where I've soldered pin 9 and 10 to be output 3 and 4 up here on the top. And that's if I want to add some sort of extra function for whatever reason in the future. I'm probably going to hook this up to a hold lamp, so that when I press the supplementary hold key and a line goes on supplementary hold condition, you'll get the rapid blink pattern from these two on your line that's placed on priority hold. But up here, I could probably make a fading condition where the line fades in and out slowly, or does some other random pattern to just add some extra pizzazz to the hold lamp, because currently I don't really have any use for my hold lamps and my phones, and I just sort of like to give them some sort of purpose. Anyway, I hope you enjoyed this video. If you have any questions about priority hold and trying to make one of these, let me know. I'm happy to help you. And stay tuned for another video, because I'm planning on getting this working soon. And if it fails miserably, I'll go ahead and still make an update just to show you how my circuit went wrong and how I'm planning on improving for another one. Thank you for watching, and be sure to check out the other videos on my channel.